Okay, this is Math 2, Unit 3, worksheet number 3, looking at triangle congruence proofs today. All right, so here we go. We're going to be looking at a lot of the information we've learned over the last couple days and putting it all together. Just as kind of a quick little recap, some things we talked about in terms of proving triangles are congruent. We talked about finding out if they have three sides of the same. We talked about finding a side, angle, side. We talked about angle, side, angle. We've talked about angle, angle, side. We've mentioned the hypotenuse leg. We've talked about the reflexive property of congruence. We've talked about that vertical angles are congruent. We talked about the definition of an angle bisector. We talked about the definition of a segment bisector. And we also talked about the definition of perpendicular. Okay, so reflexive is that line, that they both share. Okay, vertical angles are going to be the ones across here. Angle bisector is the one that cuts an angle in half and makes two equal angles there. A segment bisector cuts something in half and makes two equal segments. And a definition of perpendicular means you have two angles that then become 90 degrees. All right. So let's take a look then at some of these questions today. Looking at number one, first of all, we have the statement. First of all, let's start with our given. We can say that BC is congruent to DA and angle CBD is congruent to angle ADB. And this is our step one, and we would say this is given. So we can see that we've already marked here that that is congruent to that, and this angle is congruent to that angle. So I have an angle and I have a side, or I have a side and an angle, depending on how you want to look at that one there. For this question, I think the easiest thing to look at next is that BD is congruent to BD in the one triangle and the other triangle. And that is our reflexive properties of congruence. Okay? So now we have a side, an angle, a side. And that's enough for us to prove that triangle BCD is congruent to triangle DAB. And so that is by side, angle, side. And that's the idea there. You'll do something similar here looking at number 2. Notice that the given information talks about X as the midpoint of AG and NR. If that is the case, if that's the midpoint, that's going to give you information about that line there, being those lines being equal. We have here a set of vertical angles here, so you can prove that those are vertical there. And at this point then you have an angle and you have a line. But we also notice here, this is the NR and the AG. This line is also congruent to that one because X is, these two lines bisect, so it gives you two equal parts. So you have a side, an angle, and a side, and so you have your definition of a segment bisector happening as well as vertical angles. So use that information then to write that out in an organized way over there. I'll let you do that one on your own, okay? Number 3. This one's kind of laid out for us like this. So we're kind of filling in the gaps for number 3. How do you get from one step to the next? So we have our information that BD is perpendicular to AC. So this one is perpendicular, and that BD bisects angle ABC. Okay. So if that's a given, then what we know is that we know that AD, it says here, definition perpendicular. So what we can say for number 2, okay, what we can say for 2 is that angle ABD, oops, sorry, I got it back up here, went the wrong way, looked at the wrong one. Number 2, we say angle BDA, oops, angle BDA and angles BDA and angle BDC are right angles. All right, and they're right angles because that's the definition of perpendicular will tell me that those two angles are right angles. Good. Next, it shows that angle ADB is congruent to CDB. Okay. And that's going to be true, one, because we both already wrote down they're both 90-degree angles, and then that's going to be because all right angles are congruent. So all right angles are congruent, and that's how we would define that one for number 3, the reason. 4 says ABD equals CBD. So ABD, this one, equals CBD, this one. Now that's going to be true because that is the definition of an angle bisector. Because that was bisecting there, we got 2 equal parts. Next, I could say that BD is congruent to BD. Always seems to be BD. That's the reflexive property. So now I have an angle, side and an angle, which was my goal. So I will now say that triangle ABD is congruent to triangle CBD. And that's the idea for number 3. Alright, let's flip it over to the back side. Looking at number 6. For number 6, the first thing I need to do, put my paper down so you can see, is copy the given information into statement number 1. So we can say BD is the angle bisector of angle ABC and angle ADC. And this is simply given. So BD is the angle bisector of this one and this one. So that information gives us this. It says that this angle is equal to this angle, and this angle is equal to this angle. That's the information they give us. So we have an angle and an angle. Now, definition of angle bisector, what I just said, is now we can write this down, and we can say now that angle ABD is congruent to angle CBD. That's the definition of an angle bisector. So we're saying that one's equal. That equals that one. Then, over here it says ADB is congruent to CDB. It's the same thing, but now we're just proving that one to be true. Definition of an angle bisector. The next thing we do, again, it seems like always, we say that BD is congruent to BD. So this BD equals that BD. And that is the reflexive, right? The reflexive property of congruence. And then finally, we copy down our goal. Now we can say, because of angle side angle, that triangle ABD is congruent to CBD, like so. Looking down below at the next part here, I believe what they're asking you to do, it says to first name a pair of overlapping congruent triangles and then say why that's the case. So let's say I was looking at number 8, for example. Number 8 shows me that I have some equal parts here. And so it might help if you kind of cover up something. Maybe you use like a post-it or something like this. And so I'll cover it up and I can say, well, that's a triangle right there. So this triangle, which I could label as triangle NLP, we're going to say is congruent. So NLP, so we're going from the 2, 1, 1 is congruent to this one, 2, 1, 1, triangle MLO. Now L is in the middle because we're going to be sharing a common angle there, right? Common angle. We can look here, let's look at just one of them for example. If I look here, I have a side angle, and then this side here is that plus that. No problem. I say no problem because when I look at this triangle, it's the same, that plus that, exactly the same. So the postulate that's going to prove this to be true is I actually have, looking here, side, angle, side, is the postulate that proves that to be true because of this common angle that they share there. Because that's the same on both, that allows me to prove it to be true. You'll do the same kind of thing for 7 and 8. Again, list what triangle is going to be congruent and then talk about the postulate that proves that to be true. Alright, good luck. Hope you have a great day.